Taro Shimada is the President and Chief Executive Officer of Toshiba. He started his career at Shinmaiwa Industries, and after working at Siemens KK, he joined Toshiba in October 2018 as the Corporate Digital Business Chief Strategy Officer. Then in April of the next year, he became the Chief Digital Officer, responsible for Toshiba's digital transformation and for strategic business creation and promotion. He was then appointed CEO and Representative Director of Toshiba Data Corporation in February 2020, and President and CEO of Toshiba Digital Solutions Corporation in April 2020. Then in March 2022, he was appointed to take the reins at Toshiba as President and CEO. And last comment is that in May of that same year, he was appointed Chair of the Board of QStar, which is the Quantum Strategic Industry Alliance for Revolution, a consortium that promotes business creation with quantum technologies. So clearly someone who's had a large role in this, and I'm sure will continue as the years go ahead. Please welcome.
Well, thank you very much, Paul, for a kind introduction. I'm Taro Shimada, CEO of the Toshiba, and then also the chairman of the QStar. So I'm going to a little bit talk about the Toshiba's vision and strategy for the quantum, and then also our quantum safe technologies business. For the interest of the time that I like to focusing on the QKD this time, because not like other quantum technology, QKD is really ready. You can use it in a real situation. That's why that I wanted to focus on a little bit on that topic today. And then also introducing a QStar, our Japanese ecosystem, how we can actually try to build a quantum ecosystem in Japan. So our vision and strategy. It's a little bit busy slide, but the message is actually simple. We are focusing on carbon neutral technologies, including all those transformers and grid technologies and so forth. And then we are focusing on right-hand side infrastructure, all kinds of infrastructure we're providing from the mobility to others. And then we are trying to incorporate all those hardware product into a digital world, taking all the information out of those hardware and then elevate it to the platform you can so anybody can utilize it. And then at the end of the day, on top of this, we said that QX, which is quantum transformation, and this is the next generation of that fully optimized world for the future, what we are envisioning. So this is a kind of a step and also that kind of idea that we are having. So if you think about the 1970 around that internet is start coming around. Nobody thinks that the internet and digital economy becoming such a huge influence. And then right now, maybe some of the people who still doubt about the quantum, but I firmly believe that this will follow the similar path of the digital evolutions. And then what we call that this is a quantum evolutions, quantum transformations, and where the quantum computer is connected through the sensing technologies connected through that quantum network. So this is some of the, once again, the busy slide. I don't like the busy slide, but somehow Japanese makes a zippy thing. But anyway, this is trying to illustrate how much impact into that any area of that your life connected into the quantum. And I think at the end of the day, that will help that lots of people's daily life. So this is the kind of a roadmap that what we are doing today, and then also how we want to evolve into that our technologies. So there's a left-hand side, QKD and quantum-inspired software, and also that quantum native device. All those three things is already available. We already produce. Especially like I said, QKD is really ready. I mean, this is the matter of that, implementation or not. And in the middle, we highlighted the quantum-inspired, which is not a real quantum computer, but utilizing a quantum idea to implement it into the normal computer, which is like annealing technique. But there's other algorithm on top of this to creating optimization solutions. And the reason I'm highlighting this is already making a lot of profit already. So this is the real business already now. And this is a kind of one of the nice segue into the real quantum era. Because lots of people need to adapt the different way of the thinking when you try to leverage the real quantum technologies. And then if we are too much, I don't know, gap between the current way of the working in the digital, and then all of a sudden you have to use a quantum computer, that's going to be very difficult for many, many of the people. Maybe not problem for the people in this room, but I mean, if we really want to make the industry out of this, it is important to take the baby step and then integrate it into the current digital world and quantum world. But at the same time, we are working on the quantum devices. But this is like a real high fidelity qubit. Basically, what we are thinking is we should focusing on the very high fidelity qubit for now, because it's not the time to increase the number of the qubit. Because if you don't have the high fidelity qubit, it's just adding multiply by all those errors. And of course, there's an algorithm to correct it, but we are very much focusing on creating high fidelity qubit for now. But then after that, there's a quantum memories, which we are working on. Also the quantum repeaters and quantum relay, and then quantum communication is finally, it will becoming a quantum internet, sensing and quantum computers all connected. So I'm gonna talk about the QKD a little bit. So this is a little bit of evolution of the QKD. The originally famous Alice and Bob, and it works fine, great. But when you bring those machines into the real environment, real fiber, real noisy location, a different temperature and environment, is it really work or not? That's the most important thing. The first step you have to go through. And I'm gonna talk about many of the POCs and things like that, but it's already proven. It's already proved to be, usable in a real environment. And then going through those POCs, we actually learn many lessons that what means to be an implementation to the real environment. The mostly that we are enhancing a software so that we can make it very easy to key distribution seamlessly. And then finally, we are working on to networking, linking quantum processors. So we have a long-standing history to come over here. Almost date back in 2000, started the QKD technologies. And we having always the best technology available that day. And we are still maintaining that technology level higher, but now we are much more focusing on to implementation, high quality, product quality to the world. We are also very much focusing on to how to actually creating a software architecture, because QKD itself, you just want to implement QKD, it's simple. But the actual situation is we will have to, it makes sense to have a PQC options, and then also that maybe a different type of the QKD machines, and key management layers, and then also be able to work with a different type of system is very important. So this is the kind of an enterprise software kind of way of thinking. And if you don't have those kind of things, the QKD is just a box. But end of the day, you want to make sure the encrypted key safely transferred to A location to Bob location. That's very, very important. That's the end goal. And then we try to make it as service as possible. Because lots of people worry about the investment required for the QKD. But what we are trying is that we are actually servicing the key delivery mechanism so that you don't have to invest lots of money, down payment, but you can start using the QKD safe technologies. So here's our quantum safe network activity globally. It's keep expanding. And then everybody is working on the QSN. I'd like to mention a few. One is the Chicago Quantum Exchange. Thanks to that understanding of Professor Ashram and others quantum exchange people, we have established in 2022 the US first quantum project, QKD project. And it's keep expanding. And this is one of the demonstrations of using a QKD in effective daily basis. There's a president, a former president is there too. But there's a high school student come around the quantum exchange, and then they are experiencing that what safe quantum network meaning to demonstrating that elections, to making sure that your identity and then also that the information is really correct. Also, 2022, we bring this to a real market, the London quantum network, working together with the British Telecom. And this is where we learned a lot, actually, what mean to implement in the real environment. And then we enhance the softwares and hardware. Hardware not much, but mainly the software to be able to support the customer needs very well. So the EY and HSBC and Equinix is already start using our solution over there. Back in Japan, we also established the world's largest quantum QKD network outside of China, of course. But we are very much proud that we can have all kinds of different experimental using this QKD network, leveraging to connecting the different financial institute or research center all together. And we are very much happy about the end result of this Tokyo QKD network. And then there's a discussion we are talking about the extended into that entire Japan national QKD network. We also had the 2024, working together with the Singapore government very closely, Quantum Safe Network Plus in Singapore, which is also including a PQC, but QKD network is provided by the Toshiba's technologies. Finally, in 2025, we have an official service launched in France, Paris, working together with Orange. And this is a subscription-based services. And then there's people who are already signed up for this to get ready for the quantum-ready security. We are also working on the long range of the key distribution, which is something called twin field. This one, you kind of say that it's kind of a first implementation of a quantum repeater. So we have extensive 245 kilometers proved, and this is also that approved in the real environment in Germany and other places. We are also working on to miniaturize the QKD machines. We wanted to make it on one chip QKD so that you can implement any system as easy as possible. And we are almost there. Of course, at the end of the day, we want to connect with a satellite. So intercontinental QKD network can be served. So now I'm going to talk about the Q-Star of the Japan a little bit. So this was established 2021 September. Currently, we have 137 members. I'm an original starting member, and then also that from the beginning, I have been leading these activities, and then I'm chairman of the Q-Star right now. So this is the progress of the Q-Star. But the really main things that I need to emphasis on in the Q-Star is that more than 60% of the 137 members is coming from user side. Those are the people who are not really willing to sell the quantum products, but utilizing a quantum products and try to explore how quantum can be useful for your business. And very much business-oriented activities. It's not like use cases of a professor says that, oh, this is great thing that we have achieved. But the use cases, business people can excite it. If you can solve this problem, we'll buy you type of business use cases. And we have been focusing on to building up all those business use cases for the last couple of years. Now we start getting into that implementation phase or testing phase. So this is the kind of 3 pillars we are focusing on, how we actually extend our activity of the Q-Star. We are very much focusing on business use case. It's not the use case of, just prove the quantum is better than other methodologies, but much more focusing on how you can actually get out of this. So while you are discussing about these such use cases, it's quite naturally, you only pure quantum use cases is not really exciting for many of the business people. So we are getting much more realistic. And whether this is like a quantum inspired or this is a hybrid solution, we don't care. Basically, anything good for the business is good for everybody. So that's why we are very much focusing on how we can actually integrate current available quantum technology into digital world. In order to do this, you have to have a set of the hardware and software into the one location so you can keep testing the integration and keep exploring the use cases. It's really useful for the business people. That's why in the middle, test bed is quite important. In Japan, we decided to just invest in one location, which is the AIST, and then most of the government investment is coming to the test bed. And the idea is not really try to focusing on to developing the Japanese quantum computer or Japanese whatever. We want to have the best technology available today from the globe and install over there. We purchased many GPUs. We have a supercomputer right next to it, and then integrate, whether this is a low-level integration or high-level integration, whatever way, how you can actually get out of some of the business benefit out of this. And while we are doing this, we are learning a lot of things that where we should focusing on, or which direction we want to focusing on, or what type of algorithm we should think about, whether this is a machine learning, or optimization, or simulation. Any way we can, we want to make sure the business will be benefit to it. And this is very important. This way, we can attract many of the users, keep working on. Because, if you talk to many of the user community, there's a problem. It was like, they may be interested in the initial stage and spend 3 years. And in 3 years, well, I don't see any of the real result. Just cut the budget. And that's it. Until the real computer is coming around, or real technology is coming around. But quantum is not like that way. you have to be able to understand how quantum works in order to take advantage of that new type of technologies. It takes some time. And then also that it requires that the learning of that domain expert people to understand that how quantum can be applied. And this has to be a very open system because we don't know which modality is going to fly, or we don't know which software is going to be really useful in the future. At this point of time, creating a market, creating an industry is much more important than just compete against we are a little bit better than him or better than her. That doesn't work if you really wanted to create that quantum industry. The last piece is really the standardization. And when I mean a standardization, it's not nitty-gritty, very specific, rigid standardization. It's actually very soft, very flexible standardization. And it's open standardization. Because I see a lot of people who keep reinventing a wheel again and again and again. This is a waste of the time. Yes, I understand you want to do something, you want to get some kind of a result, but if you keep distracted by some of the development, you cannot be focusing on the core development, I think it's going to slow down the entire process of quantum industry development. So that's why, from the beginning, we have set something called quantum reference architecture model for industry. It looks complicated, but it's actually very simple. Yes. Let me explain about this one. So in the bottom, there's dimension 1, which is the industry, basically financial industry or automotive industry or whatever different industry. And then dimension 3, this one, is a hardware, software layer, which is actually the core heart of the quantum technologies, with a quantum device or module or hardware computing. But really important point to integrate into business is this upper layer, dimension 2, z-axis layer, which is what we call the architecture layer. This consists of integration, communication, information, this is a data model, and then a function, combination of the data model and then some of the functional, and then business. So what we are trying to do here is try to make the quantum as easy as possible for anybody. If you have a new idea and great new quantum computing, and then you have to change the way you work, that doesn't work that way. You must be very clever to be able to adapt. But we wanted to shield the end customer from the disruption so that you can keep using your familiar application or software, but it's all of a sudden this software becoming very clever. You see what I mean? So this is what I call the chat GPT moment of quantum. You know, chat GPT is great. Even I can use the AI everyday basis. The goal is that I can use the quantum everyday basis without knowing too much detail. And sometimes you really don't know whether you are using a quantum or not. But that's the end goal. And then we are actually, when we creating a use case, we map everything into this layer so that which layer is really relevant. You see, this is not really standard. It's just a kind of a mechanism to segregate what you're doing, just classifying what you're doing. And then also, I have to mention it, from this, the only in the bottom black part is the real quantum related part. Rest of the thing is just engineering, which I love, by the way. I'm an engineer, trained engineer. Yeah, I already explained it, so. But in order to make it happen, and especially the software engineer, we need to have a much more breakdown of architecture. So this is what we come up. We all those, clever people who is implementing enterprise architecture everyday basis and get together and then summarize this. So remember, this is not a product. Anybody who can actually be able to have a product, you can actually map it and then make it clear what role you want to play in the quantum ecosystem. You see what I mean? This will make things much easier for many, many people. You don't have to do everything by yourself. I mean, you want to focus on what you are really good at so that we can create a market together. And we decided to take this to IEC, ISO JTC3. And then we already established a working group to promote international collaboration. Is very important. I mean, there's no country who can actually do quantum by yourself. I don't think so. And so, to me, it is important to have international collaboration. That's why I'm a CEO of the Toshiba, but come all the way from Tokyo to Chicago to do this. Because I do think this is very important. And this is a picture from the G7 happening in Canada. That was an amazing experience that the people are very much excited. So this is the final slide. The Q-Star is kind of working closely with Japanese government and then proposing policies, and then so standard setting and test with R&D. And then also we are helping the startups quite a bit. All the startups in Japan is already in a Q-Star to nurture them and try to help them. And then global alliance. Remember, there's no country who can do the quantum by yourself. Committed to the people, committed to the future. Thank you very much.
Thank you so much for the vision that you've shown. Questions that people have? I'm going to start with one, actually. So
Yeah.
you talked about quantum networking, which is largely focused on quantum key distribution at the moment.
Right.
What do you view as what is the next first application beyond quantum key distribution?
Yeah, it's a good question. I mean, it depends on how the quantum computer is evolving, but connecting the different type of the quantum computer and try to scale up the quantum computer is one of the interesting. But the other one is really the quantum sensing is becoming much more available. Then it makes sense to connect with the quantum network.
Great. Did you have a question?
Yes.
Thank you so much for a great talk. ありがとうございました。
Yeah. I think you know everything.
Well, I mean, I'm also curious about your point of view because Japan quantum industry is so vibrant and then very active. So which quantum industry or which industries will benefit the most from quantum in Japan? What do you think? What will be the target industry?
Yeah, it's difficult to say, but I mean, the most the hot topic right now is really the security, right? So all the financial institute people is really focusing on how you can protect their data right now. But any kind of optimization problem, like whether this is a logistic or it's actually you can do the drug discovery using optimization too, is some of the relatively easy targets right now. Yes.
Yeah, question about QKD, right?
Yes.
So Toshiba has been leading QKD for a fair bit of time.
Yeah.
Ever since the PQC has been announced,
Yeah.
do you see like the interest or in QKD reduce, increase, or remain flat?
Well, I think it's more like it's becoming the threat of the quantum is becoming more imminent. So actually, that our businesses keep growing in the QKD side too. So it's kind of a effect of like a little bit like a deep shock. You know what I mean? You know, there is a availability of the cheaper AI, and then more people start using this. So that's kind of a feeling that I'm getting. So the PQC, QKD have to hand in hand to protect your data security into the future, and the business is growing.
Thank you so much for our distinguished speaker.